Hello everyone, this is Rahul from Learn with AI. So in the previous video we talked about matrices and there we gave an example from the rank of the matrix. So in this particular video we are going to talk another example of matrix. This is from the eigenvalues and eigenvectors. We are going to do a question from the eigenvalues and eigenvectors. So let us first of all write the question. So the question goes like this. Find the eigenvalues and eigenvectors and eigenvectors of matrix A, where your A has been given as minus 4, 2, 4, 3, minus 4, 2, 4, 3. So this is a particular matrix that is given to you and you need to find the eigenvalues and eigenvectors of this particular matrix. So this is the question. So I hope you have all noted down the question. You can pause the video and note. So to start with the solution, we have to know about the characteristic equation of the eigenvalues, or finding the eigenvalues. So this is the solution. It goes like this. Characteristic equation. So what will be the characteristic equation? If you have gone through the theory, you will be able to understand. The characteristic equation goes like this: A minus lambda I. Determinant will be giving you 0, and that is the characteristic equation of this particular format. So if we put the matrix in this manner, so what we are getting, so for this I have to rub the question and I hope that you all have written the question. So if we put this here, so we are getting, the first one will be A, so A is minus 4, 2, 4, 3. Minus 4, 2, 4, 3. This is A minus lambda. Again, it will go like, now see, I. What is I? I is a unit matrix and I totally depends on the row and column format of the matrix, and this is a 2 cross 2, so I will be 1, 0, 0, 1. So it will be 1, 0, 0, 1. And the determinant of the total will give you 0. This is the format, right? So this is the format to find out the eigenvalue or vector. Now we are going to proceed this particular format so that we can find out what is the value of lambda. And for that we need to proceed. So the first one, minus 4, 2, 4, 3. Minus, now we can put the lambda inside the matrix, so it will be lambda 0, 0, lambda. So in total we are getting 0. Now we can subtract the two matrices. So if we subtract the two matrices, what we are getting again, so minus 4 minus lambda, that's the first one, minus 4 minus lambda. Second one will be 2, because 2 minus 0 is nothing but 2. Third one will be 4. Fourth one will be 3 minus lambda. 3 minus lambda. I'm sure everyone knows how to subtract two matrices. So that will give you equals to 0. Now we can conclude that the determinant of this particular matrix will be 0. So we know how to find out determinant and we are going to follow this particular process. So this multiplied by this minus this multiplied by this. So this will go like this: minus 4 minus lambda multiplied by 3 minus lambda, and this will be minus 2 multiplied by 4, that is 8, will give you 0. So this becomes a quadratic equation in terms of lambda. So we can use factorization or Sridharacharya technique and we are going to find out what is the value of lambda. So from here if you follow the process, you will get lambda equals to minus 5 and 4. We are not doing the particular process because I believe you will be able to solve it. We are just focusing on the values of lambda. So these values are giving us the eigenvalues of lambda. So this is the eigenvalue. There are two eigenvalues because this is a 2 cross 2 matrix. So there are two eigenvalues. One is minus 5, one is 4. So these are the two eigenvalues. Now we are going to find out the eigenvectors of those eigenvalues. So I believe you have already taken the notes till here. I'm going to rub everything. Now we are going to start with the eigenvalue of minus 5 and what happens when we take minus 5 as the eigenvalue, what are the eigenvectors related to that. Okay. So when we are taking lambda equals to minus 5, so let's take lambda equals to minus 5. So this is the first eigenvalue that we have taken, and let us say the vectors related to that can be compiled in this format where x1 is the variable matrix which consists of two variables x1 and y1. Why x1 and y1? Because this is a 2 cross 2 matrix, so I believe there are two solutions that will come. So if I put it in this manner, the same old process for finding the eigenvectors, that is discriminant of the matrix form of A minus lambda I into the variable equals to the other side. So A plus y plus, okay, let us write in terms of minus only. So A minus lambda, lambda is minus 5 we have taken, right? Let us take it as a third bracket. So minus 5 into I, okay, and into x1. We have taken the variable now. Why? Because we are doing the vector now, and that is equals to 0. Okay, so we can again write it as A plus 5i bracketed into x1 equals to 0. So this becomes the equation which we need to solve. Now let us put the values one by one. So first comes the value of A. So A is the matrix that is given to us, which is minus 4, 2, 4, 3. Minus 4, 2, 4, 3. Plus 5 will be the lambda here. And I will be, okay, we can directly put 5 here because you already know the process. So we don't need to write two steps for this. 5 into I, we can directly put inside. So it will be 5, 0, 0, 5, right? We can directly put. If you don't understand, you just write 5 into 1, 0, 0, 1. And the next step, you just put 5 inside that. Okay, so after that, we will conclude this one and we will now add this matrix, which is x1, y1, and that will give a total of 0. So I hope this is clear. So next, okay, what we are going to do now, the little space, so we have to adjust a bit. Okay, so minus 4 plus 5, 5 minus 4 gives 1. 2 plus 0, that is 2. 4 plus 0, that is 4, and 3 plus 5, that is 8. And with this I will write this x1, y1, and that will give you 0. So this is the final form of the matrix from which we are going to now find out the eigenvectors. Okay, so I hope you have already taken the notes till here. Now I'm going to keep this and rub all the other things. So let us skip the last one and we have to wipe out the rest. So now what to do? So now we can put the equations now. We know how to multiply the matrices. So the first one goes like this: 1 into x1 plus 2 into y1. So it goes like this: x1 plus 2y1, that will be equals to 0. That's the first one. And the second one goes like this: 4 into x1 plus 8 into y1 equals to 0. 4 into x1 plus 8 into y1 equals to 0. Okay, so these are the two, and from this two, what we can conclude, both of these equations are the same only. So from both of these equations, we can conclude a common thing, which is x1 equals to minus 2y1, isn't it? x1 equals to minus 2y1. We can conclude this from the following. So if I put now the values of x1 and y1 in any of the terms, so what we can put, now see, we can put like this, where we can tally it with a value k. Let's say it's a constant, okay, because there are two variables, so better to put it in terms of k, where k is any particular random value, where we can change the value of k, and regarding that we will get different values of x and y. So what will be the final eigenvector? So x1 can be written as, so the first one is x1, in place of x1 we can write k, okay. Now see, one more thing, y2y1 minus 2y1 is k, so what is going to be y1? It would be k by minus 2, right? It would be k by minus 2. K by minus 2. This would be the other one. Okay, so now if I take out k from here, and we can put here 1 and 1 by minus 2. Okay, you can also write it, or you can also write it in this manner. You can write k, and this you can take as minus 2, this is 1y. You can take like this, you can say let's y1 equals to k. Instead of this one, you can say let's, we can conclude here y1 equals to x1 by minus 2. And let us say this is now equals to k. So what if this is equals to k, then y1 equals to k, and x1 equals to minus 2k. So minus 2k, k goes out, we are getting minus 2, 1. So you can represent in both of these formats. You can represent in the first one, you can represent in the second one. Okay, so now this is the eigenvector, this is the required eigenvector that we have got. This is the required eigenvector when the lambda is minus 5. When lambda is minus 5, this is the required eigenvector. Now out of this, the k is the constant one, and this particular vectors, these are known as linearly independent vectors, because these are independent of any value of k. This will always remain like this. Okay, you put k is 1, this will remain like this. You put k equals to 2, this will remain like this. So for any random value of k, this will not change. So this is independent of the value of k. That is why this is named as linearly independent variable. Okay, linearly independent eigenvector. Sorry, linearly independent eigenvector. I will write the name for you so that you can also note it down. Linearly independent eigenvector. Linearly independent eigenvector. So this is nothing but this one, minus 2, 1. This part is the linearly independent eigenvector, and this is the dependent one. Okay, so this is for lambda equals to minus 5. The same process will be also done for lambda equals to the same value, which is 4. So again, you are taking, now this time you can take x2, where x2 equals to x2 small and y2 small. Okay, so like this you will be able to understand and follow up with the particular question. So I hope you have understood this particular format, and I hope that you will be able to do questions in this particular manner, in this particular
priority. So that is the end of this particular video. In the next video, we are going to talk about the Cayley-Hamilton theorem of matrix, and this is going to be a very interesting one. So I hope you will love this particular video also. So if you have understood this particular video, don't forget to share, comment, and I will see you.